Hello everyone and welcome to another video. Today I'm going to be going through data assets, this time with a little bit of C++, that'll be fun. It's going to be using Dragon IK as my example because I think the Dragon IK is something that could particularly benefit from data assets, and I'll explain why as we go along. There's going to be a bit of setup here. First of all, you'll want to, if you're going to follow along with this video, like download the Dragon IK project. You can use any third person, blueprint or whatever you're going to do. It really doesn't matter what project you use because this tutorial is indifferent. So off the start though, open your project. This one happens to be in 5.2. Go to new C++ class. Go to all classes. Write data asset. Apparently it doesn't want to appear. There it is. So this Dragon data asset I already made. Ignore that. Choose data asset. Primary data asset is basically the blueprint derivative of data asset, and today we're working with data assets. I'm not going to work with primaries. I've had problems with them in the past, and usually related to just blueprint issues because they're chunky. So anyway, choose that. Go next. I did Dragon data asset, I believe. So it's already in use, but do that. It's probably wise to put it in a different module. In this instance, I didn't because I don't care. It's just a tutorial video, quick one. You can learn more about putting modules in your project in other videos. They're pretty common, so do that. Create a new class. That will make your project a C++ class if it wasn't, or a C++ project if it wasn't already, which some people are gonna maybe not want to do, but I highly recommend it because pretty much every game is going to eventually involve C++. So once you do that, it's going to open up Visual Studio, and Visual Studio never works because it's a giant turd, and always has some sort of error no matter what I do with it. And this is where I'm going to push Rider. So Rider is a game changer for anybody working in Unreal. I think outside of Unreal, Visual Studio, people can still use that and get away with it and not want to pull their hair out. But when it comes to Unreal, it has like better access to the API, I want to say, so that it's a lot easier to read things. Like even just giving you heads up of stuff is really nice. And I just like everything about it more. And everybody I've shown this, like using Rider, it's changed them. So I highly recommend downloading it. Anyway, once you do that, if you open Rider, because this is going to be a lot easier if you do, Rider's going to, first it's going to install its developer plugin, which takes a long ass time. I chose to put Dragon IK as a project plugin, which I really recommend you do. Managing project plugins is a little easier, and I'll do another video on manually updating project plugins, especially through Epic's bullshit with the marketplace where they never really update to the current version because they're dealing with so many marketplace people that they have to approve their plugins, and there's just that big process, and it's just better to have it as a project plugin as well. So did that, or anything that you're extending, any classes that you extend from, always have them as project plugins so that when you update your marketplace, it doesn't completely throw everything out of whack. So anyway, once Rider has installed and done its thing, it'll basically open up. You click build, it's going to work. There's not going to be any problems. You're going to have a new data asset. This data asset will be an empty thing. I've added a couple things to mine, but pretty much nothing. It almost essentially just looks like this. So the first thing you want to do if you're going to follow along with this is a very contextual thing here, is that we need to have access to include this Dragon IK module, or header file rather. But you need access to the module, which means you have to go to your build.cs, so project test plugin build.cs. This is for Dragon IK, and there'll be public dependency modules. In here, you want to add a comma, quotes, Dragon IK plugin, and if I do it again, I think it'll show me. There's a game and an engine plugin. You want access to your game plugin. So you don't want to be doing no stuff to the engine stuff. Anyway, do that and then build again, because when you build, it's going to then allow you access to this because your module says, yes, I can access this as a public dependency, which means other classes can access it. So that then allows us to add this include. So when I added this include, I specifically added the feat solver as an example because I know that it has the fdragon data multi-input in it. And the reason why I'm making this video is because I am trying to get CodeHawk to start using data assets as opposed to just the structs and all of the variables that are involved in the node. So if I open up the animation blueprint here, we go to the anim graph, you have your spine solver, or your foot solver, whatever. And these have all of this by default. So this struct right here isn't exposed as a variable like I did it on this one. And you can see all this data. And there's so many variables here, and as he updates them, or as you have, which is what I'm going to get into here later, as you have more linked layers initialized, you may have different requirements for your IK per skeletal mesh, we'll say. And although those characters share a animation blueprint and a skeleton, as you may have in a layer system like Lyra or something like that, the issue is that you don't really have the ability to modify these variables at runtime, and that's where having a data asset that promotes those variables at runtime, like as structs or whatever it's going to do when those layers get initialized, will allow you to have all of these variables inside of a data asset a lot cleaner and a lot easier for designers to access who don't understand blueprinting or animation blueprints in particular. So by doing this, you can have something like this dragon input data. How you find out what kind of variable it is, if it's a struct and you don't know, is you would promote it to a variable, and it's going to tell you that dragon data multi-input type. So that's one way to find it from Blueprint. The other way is to have access to the C++, where you right-click on it, show context actions, navigate to declaration. Now that's going to show me the foot solver here, and pretty much the first struct you're going to run into here is the dragon data multi-input. So this is, you can read what it does. It's the exact same thing. If you want to find any other variables, they're all in here, and CodeHawk is an exemplary programmer. So there's tons of stuff you can learn from reading this stuff as well. But more importantly, you know that that variable exists, and if you had tried to enter it before without having this include, you couldn't gain access to this variable. So I'm just going to rewrite this just for fun. Some things you want to do when you first make a data asset to make sure that they're going to work properly is in your U class, make sure that they are blueprint type and blueprintable, and that you add a public field above the U property. So when you do this, you can go U property, edit anywhere, blueprint read only, and let's say category equals dragon IK data. So this just allows me to edit whatever I want in my inside of a data asset, which is, you'll see it in a second. It's almost like a class defaults panel that exists within an object, which is the data asset, and then that data asset you can pull whatever properties out of it. So in this instance, we're going to go fdragon data multi-input. You can see the foot data, you can see arms, bones, struct, all these different things he has. But I'm just going to do this for now, and I'm going to call this dragon data multi-input. All right, so now that I've done that, I'm going to build the project first, just to make sure I don't break anything, because I was messing around here. I'm going to delete those variables. It's not going to hurt anything. So it's just the normal animation graph. Nothing's changed. All I've done is expose this one as a pin to show you. So I'll do the same thing here just for fun. Now they're pins. All right, so I'm going to close this. Let Rider do its thing for a second. So I can rerun this with this new variable. Alrighty, so once this is loaded, I'm just going to make a new one of these just because. We can double check that everything's here by checking your Dragon data asset is in your C++ classes. And again, that'll exist and you'll be able to make it, but if the variables don't exist, it's chances are because you didn't add edit anywhere, blueprint read only, or whatever. You do not want data assets to be blueprint read write where you edit the variables at runtime, because it will change all of the data assets that reference that. So they're just not meant to be changed at runtime. They're meant for designer tools. I'll kind of explain more about that, but really, really useful for things like UI and impact handlers or whatever, kind of like ballistic effects, but like done correctly. So we'll go data asset. I'll go Dragon data asset. So that's making one of those. Test data. Now when I open it, you can see that the struct I made, data, Dragon data multi-input now exists. And there's all that information that you'd have for those 2 feet or whatever, right? So again, this is awesome because if your animation blueprint gets corrupt or CodeHawk pushes a new update or whatever, he could push updates of all of this with the ideal settings for a humanoid, for example, or a quadruped or whatever, and they can just call it example quadruped test data or something like that, So it's really nice for pushing updates and all that stuff because it allows you to just have all of this compartmentalized into one, or encapsulated into one asset, instead of having multiple animation blueprints or, again, even having people go into your animation blueprint and edit stuff. It's pretty easy for people to mess stuff up if you're working on a team. So inside of here, we have our Dragon foot solver. Now, sort of the issue with this is that if I was to make a variable here called Dragon, where is it? Dragon data asset, it's an object reference. And I'll call this Dragon data. Okay, so compile. And Dragon data is going to let me select my Dragon test data. And now when I drag out, it's an object. If I compile, I don't know why these are not being fast pathed. But if there's a fast path on this, it's a little lightning bolt icon up here, and you use an object or quite a few other things, it'll, like a gameplay tag, for example, because it's a struct, it's going to say, oh, well, I'm not going to fast path. So if I write Dragon, you can see that there's the Dragon data multi-input right there, and that struct would go into this just like that and work. The problem is that if I was to do this, it would eliminate my fast path and make my animation blueprint significantly slower. This is not what you want, especially if you're using something that is multi-threaded or what it would be called now, like thread safe, blueprint thread safe or whatever. This is not a thing. But I thought about this a little while ago. If you were to take this data and on your layers initialized, you promote that data to a variable. That means every time I pick up my pistol or whatever, I switch to a different character or something like that, I can have it say, okay, well, when this layer gets initialized, we're going to do this data. And then this, because it's a variable now, allows us to just pull that into here, and it's going to, every time it switches the layers, update the data will work on the foot solver, it'll all be fast path, everybody wins. So it's a really good way of doing it. Now, there is some design changes that would have to be made here if CodeHawk decides to do this, but again, this is just one example, and there's another one I'll try to give after this if I can be quick about it. So if I look at this, there's all these other pins, shift speed. So let's just expose a few just for fun. I'm going to expose shift speed as a pin, which is going to be a float. I'm going to do enable solvers are already there. So that I'm not going to do, but any of these variables too, if you're ever wondering what they are, like these curves or something like that, you just expose them as a pin, make them a variable, check them out. That in Blueprint, that's one easy way of doing it. It's a vectors right here, so just cause I'll promote a vector, I guess, because it's all going to make sense as soon as I write it. But the good thing about learning this in C++ is also you're going to learn really simple syntax, and all you have to write is a header. So nothing involved in here is writing C++ functionality or anything to do with a CPP document. You can just leave them alone. But right here we do have shift speed exposed, and we have our overall post solved offset, whatever that is. So I'm going to close this and go back to my writer. Now, assuming I wanted to add those two variables in the same area, I don't know, I'm just, again, doing this just because. We're going to write ustruct. It's going to be blueprint type. It's going to be called f dragon test data. Why not? This struct is going to contain multiple variables just because I'm feeling that way. So we're going to go uProperty, and then I will do a float, and I forget what it was called, so I'm going to call it test float. And then it's a good practice to, again, learn the syntax by writing its default variable. So you'll see why this is, you have to learn this kind of in a second. But if I write that uProperty, I'll do another one. This one's going to be a f vector. Test vector, no, I don't remember what it's called, test offset vector, whatever. And then this, in order to have its default, you can't just go like you'd think, because it's not going to work. Like this is what you'd think the default would be, right? But it's not, because it's not an f vector, it's just 3 floats that you wrote. So you have to write f vector, and then a bracket, 0.0f, 0.0f. End. So now we have our default value right there, and our default value for our float. So we're not going to have any warnings in our build when we do it. Otherwise, sometimes you'll get warnings and tell you these variables haven't been initialized or things like that. So then we'll write edit anywhere, blueprint read only. And most of what you do here is going to be kind of a copy-paste thing, but I strongly recommend that you just get used to writing manually, because although you can copy-paste, it's way better to practice your typing, practice your syntax, get used to it. Like, it's not going to take an exorbitant amount of time, and in fact, the more you do it, the less time it'll take. So we now know that f dragon test data is the struct that's above here, as you can see right here. So this struct exists in the, it's basically in the includes. It's like this thing knows that this exists, but it's not a usable variable until you make it a public accessible blueprint type, blueprintable variable. So you want to do dragon test data as a variable as well down here. This makes them exposed uProperties, right? So there's that, and then let's say I don't want to add a struct. I'm just going to add a uProperty, edit anywhere, blueprint read only, category, same thing, why not, dragon ik data. This one's going to be a bool, and it's going to say hello, and equal false by default. So, actually I'm just going to cut out this tutorial bool. All right. So now I've created a non-struct variable. I've created this struct which has access to these two variables, and everything looks good and nothing has any angry red stuff. So that means that it's probably going to work. We'll give her a build. While I'm at this, I'm going to shamelessly pitch my new plugin I have coming out. So I have an animation plugin that I've built. It's going to be called Gate Locomotion System, if you keep an eye out for it on the marketplace. And essentially what it is just a locomotion system that replaces ALS or Lyra. But it's a lot more user-friendly, and as you can see by the performance statistics here, it is a lot faster. This is the community C++ ALS with one character running, and it's like 3-4 times the MS on most things. So yeah, keep an eye out for it. Should be pretty awesome and very designer friendly, and I'm hoping to incorporate a lot of use with like Gas Companion, Dragon IK, and a few other things in the future. So okay, the build succeeded. We'll run it. Close Visual Studio forever. Okay. Okay, so now that I open this, this is my thing I had open before, Dragon test data, test bool. I do notice that this is not... Oh, right, it's because it's a struct, but it's not modifiable in here because I didn't make it like that. And then there's tutorial bool. So the issue is that because these are not editable, or at least that I'm in the way that I did them because I didn't make them. Let's change that. I don't like that. Boop. Okay. So we're going to go edit anywhere. And we'll just put them, I think the Dragon IK category was actually just called data. So I'm going to do that. Read only. Category equal quote data. Alrighty. So if you don't expose them, you can set them in here and they'll be set to these default values, and then you can't edit them inside of Blueprint. So but I think you still want to put Blueprint read only on them so you can actually get them. I'm not 100% sure on that actually. Yep. So now they're exposed. You can see my test float, my test offset, and my bool, which I'm now going to check. So I'll set that. I'm going to set this to, I don't know, 7.6 or 7.53 apparently, whatever my fingers typed, and my test float will be 5.5. So we'll go back to here. Dragon is setting this on layers initialized. Because I'm not initializing any layers though, what I am going to do is just put this down here so that it's actually doing its thing. And let's see. We got our Dragon test data. I can promote that to a variable. Actually, it doesn't matter. This is not functional stuff. This is just pseudocode. Stick this back on there. Anyway, this is what you do normally initially, is do this. And you can also split these structs and set them individually, should you so choose. But essentially you can have that test data there. And then inside of here, because you have now Dragon test data as a variable, where is it? Dragon test data. I can now break this and put this into here. So now that I'm looking at this, I think because, again, like I said before, this is a struct, and I'm breaking this struct in order to put it into here. Oh, no, it still works. It's still fastpath, so that little lightning bolt stays. I thought that would go away if I used a struct. So this method definitely works like this, and would allow you to, again, set those variables through just one of these, which is way nice. You know, if you want to test to make sure they work. Can always just break this here, print a string, and we'll print our test vector. And it's 753. So, yeah, that's kind of a basic rundown on data assets and how you can use them. The context is probably a little weird for this video because it's something I want done to a plugin that I use a lot, more than something that I would do myself, because otherwise you'd be sitting here exposing all of these pins and all of these variables, and as you can see there is a lot of them. And I feel like personally that a lot of these can be consolidated, especially considering these two solvers have things in common. And you could just pull the data and plug it in and it would be a lot less headache, especially when it comes to, let's say, switching layers, doing anything like that, because you can't edit the defaults and you shouldn't edit these at runtime, but you can have different data assets and those data assets can be set externally, which makes the whole process a lot more encapsulated and make it a lot more sense. So yeah, I hope this helps, and I don't think there's anything else I have to go over. I will say though, while I'm at it, another really useful test case of this is using it for, oh, my dog came to visit, using it for UI, because especially for colors, you can store colors inside of a data asset that are your primary colors for your UI, for example, or for whatever theme that you have to your game. You see, these are the colors we are using for our game. This is our master color index. And all of that data can be plugged into a select, like a gameplay tag select, for example, or something like that inside of your widgets. And then you can select all of those simply by selecting a tag. So what it does is it takes the control away from the artists and gives it to the art lead in that respect, that people on your team who may not know the exact hex color of a specific thing can just select, okay, green 01 or primary green, secondary blue, whatever you're going to do. And you'll expect those UI elements to just change from a tag, which is really nice, as well as nobody can mess up those hex colors. They're sort of hard-coded to the data assets, whatever your artist says, no, this is the master color index. So I really recommend using it like that. So yeah, I hope this video helps, and I'm going to call this one right now.